freshwater, benthic, macroinvertebrate identification. So today we're going to spend maybe hour and a half-ish going over the 22 different taxa that are most commonly found here in New Jersey. We're just focusing on those taxa that are on our macroinvertebrate tally sheet. So there's definitely other bugs that we might find out in the stream. We just wouldn't necessarily tally them for this assessment. So first, let's talk about the taxonomic classification system. We get more and more specific as we go down this pyramid. So we start out with the domain, and then the kingdom, come down to phylum, class, order, family, genus, and species. And so as we move down this pyramid, we get more and more specific. So if you think about us as humans, at the class level is where it kind of determined that we're mammals, and then we kind of move down and down this. So there's lots of organisms that may look different that could share the same taxonomic classification. Now, with our system, we will be identifying our critters kind of at the order and family level. There's still some diversity in those categories. We're not going all the way down to species. In some cases, we will be hovering even closer to the phylum and class level. Things like worms and leeches, we're not going to identify any further than just saying it's a worm or a leech. So it kind of simplifies it for us. And so here is that tally sheet again with all of the different taxa that we're after. So in that class category, we've got our clams, mussels, and worms. In a subclass is where we divide out the gilled snails and the leeches. Our orders include caddisflies, mayflies, stoneflies, crayfish, and scuds, and lunged snails is a bit of an informal group around that order level. Damselflies and dragonflies share the same order, but we differentiate them based on their suborder. And then everything else is identified to the family level. So you can see we have a bit of a mix. Now, within each of these categories, as I mentioned, there's some diversity, of course. With mayflies specifically, there could be 19 different families we might find. Now, of course, here in New Jersey, we do tend to find the same taxa over and over again. So you'll kind of get used to visually the specific types of mayflies that you've got in your streams. But it's important to kind of stay open and to think about the characteristics that define each taxa and not to get bogged down too much just in identifying the same one that you see every time, and anything that looks different you're trying to categorize somewhere else. That's not necessarily the case. You can see with the beetles, we've got over 18,000 aquatic species, but for our data sheet, we only look for one family. That's the Elmidae, the riffle beetles. Actually, two, also water penny beetles. So before we get into the list of the 22 specimens, let's just go over some basic insect anatomy. I'll be coming back to these words kind of as we move along. So let's just kind of all start from the same place. So insect larvae, or insects in general, tend to have three parts to their body. We've got the head. This is, in this example, can you see my cursor? You know what, I'm going to turn it to the red dot thing. Let's see, here we go. There we go. So this first segment on the insect, that's the head capsule. And then the next three segments below that, 1, 2, 3, those are the segments of the thorax. That tends to be a 3-segmented section. Along the abdomen here, you don't see the dot? Can you not see the laser pointer? Oh, dang.
I can see it.
You can? Oh, geez. That's so strange. It's like the other day when the poll didn't work for half the people. It maybe if you're a guest, you're not seeing it, and if you're a team, if you have like a Teams account, you could. Gremlins, for sure. That's what's going on. So we'll just try our best, and I'll try to explain it verbally. So on this image, To the left at the top, this is a net spinning caddisfly larva. We're talking about the head capsule. Below that, 3 segments of the thorax, and then below that, we have the abdomen. Now, at the end of the abdomen, we could have prolegs. In the bottom image here, this is a midgefly larva, and you can see that there are prolegs just below the head and also at the end of the body. We could also have at the end of the body some tails, and we can usually the number of tails will tell us a lot about who this organism is. So usually 2 or 3 tails. And these filaments, filament kind of means it's just long and hair-like, so very thin. Some of our insect larvae have developing wing pads as well. So you may remember from day 1, we talked about the life cycle of insects. And the complete life cycle, where we have the insect going through a pupation before they come out as an adult. Now, in the incomplete life cycle, the larvae resemble much more closely the adults. And so you can see these adult features coming out in the larva as they grow into these larger and larger instars. So in this image all the way to the right, you can see these wing pads. These are these triangular bits right at the bottom of the thorax. They're usually hanging over onto the abdomen. And those clearly, as they come out and emerge as adults, will come out and the wings will kind of slide out of that. We saw that GIF image. The other thing I want to mention, so prolegs are kind of the basic type of leg. It's just kind of a stump, really. But we can also have jointed legs, and that's basically, you've got the 3 parts of the leg, it kind of joints that helps it to move and walk around. And then we have tarsal claws or toes, you could call them, at the end of those legs as well. So we will start with the mayflies. This is in the order Ephemeroptera. These can be about a quarter of an inch to an inch long. So sort of small, but there's a big range of sizes. You'll see that we have this defined head capsule. The eyes are usually pretty well developed, and you may see antennae, you may not. On the thorax, on each of the segments of the thorax, you have a pair of jointed legs or segmented legs. You can see got this buff arms. This is a crawler, so it's adapted to really move around pretty well. And at the end of these legs, we have 1 tarsal claw. So you may not be able to see in this image, but in upcoming images, we'll get a look at that. Mayflies will have developing wing pads, but depending on the age of the mayfly and just how far it is in its development, it may be sort of inconspicuous, or it could be super, super obvious, all along that range there. But a very important part to the mayfly is that it will have gills along the side of the abdomen. This is a big thing to remember for the mayflies, the gills along the side of the abdomen. And then at the end of the body, we have either 2 or 3 slender tails, these tail filaments. So these mayfly nymphs come in different body types depending on their habit of locomotion. So the crawlers have those, and clingers have the buff arms. The swimmers are a little bit more lithe and can undulate underwater. The burrowers have really cool tusks at the top of their head that help them to burrow down into the soft sediment. So these gills along the side of the abdomen can look very different for different species. And we could have them very wide and rounded. You can see the soft tissue coming off of the side of the abdomen. That was for the image on the right. For the image on the bottom left, we can see that they're a little bit more filamentous and forked. So we have a bit that comes out and then they separate into kind of 2 filaments at the end, or they could be rounded and more separated. We can also see some diversity on those tails. So this image on the right, we've got 2 tails. They're pretty widely separated. The images on the left, we have 3 tails. On the top, we have some coloring. That's actually kind of cool. We can have some hairs kind of coming off of those tails as well. Or they could be really long and really separate. So lots of diversity. We're just looking for tails and gills. Those gills are going to be your soft tissue. They're going to be the most delicate part of the organism. So what's good about the method that we're using, I mean, besides the fact that we're not killing any of the insects, is the fact that we get to see them live and we get to use some of those indicators to help us make our identification. So with the gills, especially when you collect them, you have them in your bucket, it's kind of a low oxygen environment. They're coming from the stream that's always moving, oxygen's being introduced. Then they're in this bucket that's stagnant, maybe under the hot sun, and you're kind of scooping them out. Those gills are going to be moving pretty good. So you can look for that feature. The gills may also come in other kind of shapes and sizes. On the bottom here, this is kind of a squarey, rounded gill. There's two gills that are just kind of hanging off at the top of the abdomen. And then in this top example, it's tough to see, but there's more filamentous gills at the top of the abdomen, and they're kind of wrapped around to the top of the organism. So again, you'll see this live and you'll be able to see those gills move. That will be super helpful. So moving on to the stoneflies. The stoneflies are kind of in that same size range, maybe a little bit larger, 1/2 inch to 1.5 inches. They have the same general features: the head, 3 segments of the thorax. Each segment of the thorax has a pair of segmented legs. You may remember that the mayflies only had 1 tarsal claw, just kind of something that looks like a hook at the end of each of those legs. But the stoneflies and a lot of the other organisms we'll be looking at have 2. So you can see at the end of those legs, it's kind of like two bits that have separated. Those are the 2 tarsal claws. The stoneflies, this is a big thing to remember. They do not have gills along the side of the abdomen. Instead, they may have visible gills along the thorax instead. So because we can see these under each of these pairs of jointed legs, we call these hairy armpits sometimes. It kind of helps us remember. These stoneflies have hairy armpits. They do not have the gills along the abdomen. Now, the stoneflies at the end of the body only ever end in 2 tails. So the mayflies could be 2 or 3 tails. Stoneflies is only ever 2. Here's a look at some particular species of stonefly. We can see that we have 2 pairs of developing wing pads on the back. In this image on the bottom, those wing pads are pretty well developed. We can see that triangular shape very obviously. The image on the top, they're kind of a little bit smaller, a little bit more inconspicuous. And so sometimes when we're using the key and it's asking, does it have wing pads? We have to look very, very closely and kind of imagine how this specimen will look after it grows up a little bit. But we can see that we only have 2 tails for both of these specimens and no gills along the abdomen. There's a few types of stoneflies that look a little different than the other kinds. So in the top here, we have a stonefly that has kind of a hardened, I don't know how you would explain it, but it's a bit of the exoskeleton that's kind of poking out along the abdomen. We don't want to confuse that with the gills. Because the gills are going to be the soft tissue coming off the side of the abdomen, where they're going to have a lot of movement. Here with the exoskeleton, if you were to feel that with your finger, it would feel hard, like, I don't know, chitinous. But you can also see on the bottom, we have other stoneflies that are a little more compact. And these gills, the hairy armpits, the gills on the thorax, come in these double kind of pointed gills just under each of those segments. So some weirdos in our stonefly group. Damselflies are another that share some of the same morphological characteristics as the mayfly and the stonefly, which is why I grouped them together. They have the head, they've got the 3 pairs of jointed legs, and they have what look like three tails at the end of the body. Those what look like tails are actually gills, and they tend to be a little bit wider and paddle-like. And so just as with the mayflies along the abdomen and the stoneflies along the thorax, the damselfly gills at the end of the body are going to be very, very sensitive, and you may see them move a little bit as well, and that will be helpful in your identification. A really cool part of the damselfly as well is this lower labium. This jaw extends out and is able to capture prey to bring it back to eat. So here's another look at a damselfly catching a, I think, mosquito larva. So thank you, damselfly. And those paddle-like gills at the end of the body, in this top image, you can see them. They're kind of like sticking up a little bit. They're not always flat and sticking out very obvious. So when we're counting up, number of tails or number of features in a certain area, we want to kind of look in all around the organism, see if tails are stuck together, try to separate them if we can. But there are some damselflies that do have thinner gills, and so they may resemble the tails of a mayfly. So in this case, we have to have something else to go back to make this identification, because a mayfly will have the gills along the side of the abdomen, and this damselfly does not. So we want to make sure that we're not just looking at tails, we're not just looking at gills. We want to take in all of these different features of the organism. Another really helpful thing for the damselflies is to flip it over and to see if it's got that prehensile labium. You can take your forceps. I wouldn't do that actually if it's a live specimen, but if it's a preserved specimen, you can take your forceps and kind of pull the jaw out, and that will kind of say, oh, okay, that's not a mayfly, this is a damselfly. And here's another look at those very sensitive gills at the end of the body. We can lose a few in the process, so we want to just kind of be a little bit gentle when we're sorting our bugs, but also just take note that we may be missing some features as the sampling process goes on. So to summarize the differences between these three taxa, the mayflies will have gills along all or most of the abdomen. The stoneflies may have visible gills along the thorax, or you may not see any gills at all. The damselflies' gills will be at the end of the body, paddle-like, what look like tails. So for the mayflies, another thing to look at is they've got the 2 or 3 tails, hair-like filamentous tails at the end of the body. Stoneflies only ever have 2 tails, and the damselflies will have those wider paddle-like gills at the end of the body. Mayflies will have 1 tarsal claw, one of those toes. Stoneflies and damselflies will have 2. And the damselflies, of course, have that mouth part that can extend out. So if you're not sure, you can always flip it over and see if it's got that, what looks like a mask on the underside of the head. Another organism that has that lower labium that is able to extend out, has that mask, is the dragonfly. This is in the same order as the damselfly, but a different suborder. Now, dragonflies can be anywhere from a ½ inch long to about 2 inches long. They can get pretty large. They have a head, they have the 3 pairs of segmented legs, and the abdomen, the other ones we were looking at, it's kind of streamlined from head to abdomen. With the dragonfly, it's a little bit more bulbous at the end of the abdomen, and we've got 3 pointy bits, 3 spikes at the end of the body. Sometimes, again, these are more conspicuous than other times. Here we can see those 3 spikes very, very well. This is a side view, this image of the head of a dragonfly, and you can see that lower labium just resting against the bottom of the head as well. So here's a look at just the different body types of the dragonfly. You can see that the abdomen tends to be a little bit rounded at the bottom. And they come in very different sizes depending on the actual species. Sometimes you'll be able to see the pair of wing pads very, very well. So in this image or the specimen on the bottom, you can see those two pairs of wing pads pointing down. On the top, it's a smaller specimen, so it just won't be as obvious to you. You can also see that the spikes at the end of the body may be super visible. So in this bottom image, we see two spikes and there's a third right there in the middle. It's a little tough to see. But in this specimen on the top, you can kind of see spikes, but it's more difficult to see. So I think the most important thing to consider with the dragonfly is that there's no filamentous tails and no paddle-like gills at the end of the body, just spikes or really nothing at all. Here's just some more gratuitous images of dragonflies because they're so cool. Sometimes people will look at them, the very long-legged varieties, and think that they're spiders, but of course, these only have 6 legs and spiders would have 8. And here's a look at the underside again of the head. You can kind of see how it might resemble a mask, just this covering under the head. And then on the right, there's a look at it extending out. And that's in comparison. On the bottom image, this is a mayfly, and you can see that there's no visible prehensile bottom jaw that's covering. So that's just so you can see the comparison for the underside of the head. Dragonfly on top, mayfly on bottom. Moving on to our caddisflies. This is in the order Trichoptera. Same general size range, about a 1/2 inch to 1.5 inches long. They have the same characteristics as the other insects, a head capsule at the top, followed by 3 segments of the thorax. These thoracic segments may have this chitinous kind of hardened shell on the back, or they may not. So in this example, we only have this hardened shell on the first thoracic segment. So I hope you can see that. We have this head capsule here. Just below that, a hardened thoracic segment. And below that, we've got 2 more thoracic segments, but they're fleshy. So you can see that. Now, the 3 pairs of segmented legs are coming off of the side of each of those thoracic segments. And below that, we have the soft, fleshy abdomen. It kind of looks caterpillar-esque. At the end of the body for the caddisfly, we have a pair of prolegs. And at the end of each of those prolegs, there's a hook as well. So this helps it to be able to kind of hook in and construct a case around its body out of found materials from the environment. We'll get a closer look at that in just a sec. Here's 2 other examples of our caddisfly. You can see the hardened head capsule. It's kind of the color difference to be able to see it. Below this, both of these specimens just have 1 hardened thoracic segment, and the latter 2 segments of the thorax are just fleshy. And then at the end of the body, we've got the 2 prolegs, each with a hook. Here's another look at caddisflies. We can see sometimes that their mouth parts are very widely separated. At the top, their colorations, they can come in so many different colors, greens and reds and oranges and yellows and browns. So some of them may also have hairs on the side of the body, and this is another feature that helps them to construct that case around them and to be able to kind of hang on tight. Here's a look at a caddisfly who's making a case of its own. So you can see they're very industrious. These are the guys that secrete that underwater silk, and that's how they attach these materials to the outside of the body. Now this guy, I'm not sure what he's doing, but most of the caddisfly as species will construct cases that are very specific to their species. So you can see here we have some that create these kind of square-8 sections where they strip bits of bark and wrap them around themselves. They could use very small bits of sand to just kind of stick around in this kind of round pattern. Other taxa may take little bits of gravel to attach mixed with sand. In that last example, I think he had a snail shell that he found to attach to him. They could use vegetation as well. So it's pretty cool to actually find a caddisfly in its case. We don't need to rip it out of the case to make that identification. We can just say if there's someone home, inside the case, we would just count that as one caddisfly and we can move on. Now, not all caddisflies are found in a case, so we'll look at some other examples here soon. But when the cases are found in the environment, usually in an area with a lot of cobble, you can see that they blend in pretty well. So on this top image, these are small sand grains that have been wrapped to make that case, and they blend into the rock. So when we're picking up the rocks to scrub into the net, this is another one that we want to make sure that we're really getting off. They've secreted that silk. They're trying to adhere to the rock pretty well. Just a nice little nudge will usually get them off the rock and into the net. The image on the bottom shows a few other types of caddisflies that are using bits of gravel instead of sand. So just a mix of materials. Here are some caddisflies that don't make cases, but we still classify them in the same category. So caddisfly is a caddisfly, but look how pretty they can be. Oh, I just love them. There is one type of caddisfly that we do separate out from the rest, and this is on your tally sheet. You'll see a line for caddisflies, and then you'll see a line for net spinners or net spinning caddisflies. We separate out the net spinning caddisflies because they are just so much more common than most of the other types of caddisflies that we find. So you'll remember that the one of the reasons that we're doing this in the first place is because each of these taxa have a numerical pollution tolerance value assigned to it from 0 to 10. So in general, caddisflies have a lower tolerance to pollution, so they skew in that 0 to 1 to 2, 3 range. However, the Hydropsychidae, the net spinning caddisfly, has a higher pollution tolerance value. So we want to make sure that we're not falsely elevating our water quality scores if we were to lump this one in with the rest of them. So we're separating it out. Luckily for us, this does visually look pretty different from the other types of caddisflies. So for one, it does not build cases. You will never find a net spinner in one of those constructed cases. You may, however, find it in a net that it has spun. This has the hardened head capsule at the top, and we have 1, 2, 3 thoracic segments below that. Now, each of those segments will have a hardened plate on the back. So you may remember when we were looking at the caddisflies just now, most of the examples we saw just had one, that first thoracic segment had that hardened plate. The other two were fleshy. With the net spinning caddisflies, all 3 of those thoracic segments have the hardened plate. Also, on the underside of the net spinning caddisfly, the underside of the abdomen here, you can see that we have tufts of gills. They're kind of brushy and bushy. They should be very obvious to the eye, so you just kind of flip it on its side and you should be able to see those gills sticking out. We also have the pair of prolegs with the hook at the end of the body. You may also see some gills, just kind of a tuft sticking out at the end of the body as well. So looking more closely at different kinds of net spinning caddisflies, the color variation exists within this particular family as well. But you want to make sure that you're looking for the main characteristics of the net spinning caddisfly, which are 3 hardened thoracic plates and the gills on the underside of the abdomen. So you can see in both of these examples, we have the head capsule and 1, 2, 3 hardened plates. The image on the top, we have a little bit of sand or schmutz on that last, on the 3rd thoracic segment. So it may look like it's fleshy, but it is hardened. And then on the bottom example, I hope that's a little bit more obvious. 1, 2, 3 thoracic hardened plates. And then on the underside of the abdomen, we have those bushy gills. So finding these in the environment, as I mentioned, you could find them just kind of free in your net, or you could find them inside one of these cases or having constructed some rocks around them, just kind of to buffer their net a little bit. But this is just another one where you kind of rub the rock a little bit and they'll come off very easily into the net. To summarize the differences between these caddisflies, our regular caddisflies will have 1 to 2 hardened segments on their thorax, while the net spinning caddisfly will always have 3 hardened segments on the thorax. There is one example that does have 3 hardened segments, Helicocycidae, but we very, very rarely find it, and it does not have the gills on the underside of the abdomen. So I hope that if we do by chance ever find this, we wouldn't falsely confuse it for a net spinning caddisfly. But those gills along the abdomen, definitely a key indicator. All right. Do we have any questions as we're going so far? We're good. Everyone's still awake. All right, I'm gonna keep going. So our next specimen is the Helgermite or Dobson fly. We use these terms sort of interchangeably. A Helgermite just refers to the Dobson fly larva. Specifically, that's a term that the fisher people might use. But a Dobson fly is just kind of the regular common name of this organism, whether it's in the larval or adult phase. These guys can be pretty big, as small as 3/4 of an inch, but generally larger. They can get up to about 4 inches long. Their head, we see a very large mandibles pointing out, and if you do stick your finger in between those jaws, it will clench. So you don't want to just go poking around a Helgermite head. Below that head, 3 thoracic segments, each with a pair of segmented legs. But then below that, we have a fleshy abdomen, and each segment of the abdomen has a pair of lateral filaments or hairs coming off, or not like a hair, kind of just like a very hair-like filament off the side. And so there's 8 pairs of those filaments along each of those abdominal segments. And at the end of the body, we have a pair of prolegs, each with a pair of hooks. So sometimes along the abdomen, we could have gills as well that are kind of in between those segments. The image on the bottom shows what that might look like. It could be kind of white and fluffy. The image on the top left shows one where those gills are not visible. But in all of these cases, we can see very large mandibles at the top of the head. We've got the filaments coming off the side of the abdomen below those segmented legs. And at the end of the abdomen, the pair of prolegs, each with a pair of hooks. The alder fly is related to the Dobson fly, but it is much, much smaller. So whereas the Dobson fly could be 3/4 to 4 inches long, the alder fly tends to be 1/2 inch to 1.5 inches long, usually smaller, in the smaller range, 1/2 inch to 1 inch. They kind of look similar. So the head, we have the 3 thoracic segments, each with a pair of jointed legs, and we have the lateral filaments coming off of each of these abdominal segments as well. Now, this is going to be pretty small. You're not going to have a super magnification in the field. So counting the number of filaments may not be super, super helpful for you. But you can look at the end of the body to see how it ends. Remember, the Helgermite had the 2 prolegs, each with a pair of hooks. The alder fly only has 1 single tail, or 1 single filament at the end of the body. The alder fly is much smaller, as I've mentioned, than the Helgermite. It does have powerful chewing mandibles, but because this is so small, there's much less opportunity for it to be able to get around your finger and actually bite you. Some more looks at the alderfly. The lateral filaments along the abdomen sometimes are sticking out, very obvious. Sometimes they're kind of pointed down. This is just soft and fleshy. If you kind of poke it with your finger, it's not like it's gonna get you or anything. And then at the end of the body, again, we've got that single tail. So to summarize the differences between the alder flies and the Dobson flies, they both have those lateral filaments along the abdomen. The Hellgrammite will have eight pairs of those filaments. The alder flies will have 7 pairs of those filaments. The Dobson fly will have the 2 prolegs at the end of the body. The alder fly will have 1 tail at the end of the body. But the first thing that you see if you were to see these next to each other is the size difference. The Dobson flies are much larger generally than the alder flies. So moving on to our beetles now. We'll start with our riffle beetle larva, family Elmidae. Now these tend to be quite small, less than a ½ inch long. They are beetles and they have this chitinous kind of covering all the way from head to tail, from head to end of abdomen. And they tend to be kind of dark brown or black. Because they're so small, they kind of tend to look like little black commas in the bottom of the tray. And you can kind of see them move a little bit. Sometimes you'll see some gills poking out the end of the body here. But generally, they'll just be a little tiny comma. They do have 3 pairs of segmented legs along the thorax. So we have the head capsule, 1, 2, 3 segments of the thorax, each with a pair of segmented legs, and then the rest is the abdomen. So here's just another look at our riffle beetle larva. And you can see at the end of the body, if that operculum is open, you may be able to see that gill kind of poking out. Here's another look, just side by side. At the top image, the operculum is not open. The bottom, it is, and you can see those fluffy white gills sticking out. It's not common with the taxa that we find that we'll find both the larval and adult phase underwater. But for riffle beetles, the adults do remain underwater. So we can find them in both their larval form and their adult form. The riffle beetle larva, quite small, less than about a ½ inch. The adults are even smaller. They can get down to a 1/16 of an inch, generally less than about an 1/8 of an inch long. They look like a beetle, They have 3 pairs of segmented legs along the body. And this is a tough one. Oh, sorry. Go back. This is a tough one because we do have other types of beetles adult beetles that we could find in the stream. This is very difficult to identify if you don't have a microscope because it is so small. So generally, we tend to clump all of the adult beetles we find into this category. Water penny beetles, this is back to the water penny larva. So these are called a water penny because they kind of look like a penny, right? They have this copper coloring on the top. Now, if you were to flip it over, then you will see the underside of this body. It kind of looks like a mayfly under there. The head, 3 pairs of segmented legs, and we have gills along the abdomen as well. It just so happens that it has this really great adaptation. So it's able to adhere onto rocks and camouflage itself on rocks as well. So here's a look at a water penny beetle larva on the side of a bit of cobble. You can see here how important, again, scrubbing those rocks is to get all the organisms off of these bits of cobble that we'll be picking up. You want to get those caddisflies off. You want to get these water penny beetles off. And then you want to examine your rock after that. Just make sure that you've gotten everything. We are moving on to our true flies. This is the first one, the water snipe fly. So in the fly group, everything I've said so far, I feel like I've said 3 pairs of segmented legs a million times already. But in the true flies, we don't have those segmented legs. Generally, we'll just have some legs at certain points along the body, or just some appendages to kind of help it wiggle around a little bit. But with the water snipe fly, the head is rather pointy. The head can actually be retracted back into the body. So you can see this little bit poking out at the top. So pointy head. And then at the other end of the body, at the end of the abdomen, we have this V shape, these hairy appendages coming off. And that should be pretty obvious. You should be able to see this V shape pretty well. And then if you were to flip it over, you'll see that there are prolegs along the underside of the body as well, which you can see in the image on the bottom. So again, pointy head for water snipe flies, V shape at the end, and prolegs along the underside. Crane flies are another type of fly. They have a more rounded head, and it's kind of the same situation that it can be retracted back into that body. The crane flies tend to be plumper than the water snipe flies, a little bit just kind of chunkier. And at the end of the body, we've got kind of looks like a star shape sticking out at the end of the abdomen here. These are spiracles, and I believe we'll get a better look at different kinds of spiracles. So in this case, the head in both of these images is on the right-hand side, and the end of the abdomen is on the left-hand side of this image. So we can see the head on the right. In this image on the top, look at these tiny, tiny antenna sticking out. That's its little baby head, but most of the times, again, it's kind of retracted into the body. But on the left-hand side at the end of the abdomen, we can see those spiracles. Sometimes they're a little bit more compact. Sometimes they're much longer, kind of sticking out. We also have some crane flies that have either very deep segments along the abdomen, or we could have creeping welts on the underside of the abdomen, just kind of help it move a little bit. The image on the bottom shows these welts. These are these black marks along the abdominal segments. And in the image on the top, we have the last segment, this final abdominal segment that is enlarged. Again, the end of the abdomen is on the left side. So if you see this bulbous bit at the end, it may throw you off. But if it has the spiracles after that, and it has that rounded head, you are likely still working with a crane fly. Now, the black flies are also a little small, less than about a 1/4 inch long. These have that distinct capsule head. It's a hardened head. In this image, the head is right on the top. And then below that, we have a single proleg that is sticking out just below the head. Sometimes on the head, you'll see very distinctive fan-like mouth parts that are sticking up that help it to filter those fine particulates from the water. The body has kind of a bowling pin shape, so it's more bulbous at the end of the body. And at the end, we may have an image here. No, we don't. But at the end of the body, it's a little bit sticky. So you can see in this image on the top how they kind of nestle down into the sediment and can stick there. So on the left, we don't really see those brushy mouth parts. On the right, these two examples, we do. And so you can kind of see them in either way. Midge flies, another type of fly that we'll find a very, 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 very common macroinvertebrate, likely in every sample we take. These can be quite small as well. They do have the capsule head and a pair of prolegs below the head. I can't really see here, but we'll get a better look in the next image. And then we also have a pair of prolegs at the end of the body as well. So these can come in a wide variety of colors, all the way from what we call blood red through the oranges and yellows to white to basically transparent. But in all of these cases, we have this hardened capsule. We have a pair of prolegs below the head and a pair of prolegs at the end of the body. And we can see that in both of these examples. The prolegs below the head and at the end of the body may be small, like they are in this bottom image. They may be very large, like they are in the top. You can see that proleg sticking out at the end of the abdomen. And here's another look at a few different types of midges next to each other. So you can see the range of sizes we might find, and the range of the size of the head in relation to the rest of the body as well. This image on the bottom, we've got a huge head in comparison to the rest of the body. And then in these top examples, the head's a little bit smaller. But I hope that you can see that that head has that hardened chitinous capsule. That tends to be pretty helpful when we're making our identifications. We don't want to confuse this with, say, a worm, right? So we want to look for these features along the body that will help us to distinguish. The hardened capsule head and the prolegs will be helpful here. So now we are moving on to our crustaceans. We will start with our scuds. Scuds are also called side swimmers. That's because we often find them on their sides swimming around. So they're laterally flattened from side to side, but they're usually on their sides. So you can kind of see this broad view of the side of their body. They have two pairs of antennae at the top. So the head is towards the right of this picture. And then we have 7 pairs of segmented legs, and the first 2 are kind of modified for grasping and moving, so they tend to be much larger. Here's some images of scuds in the wild. You'll see all of them are on their sides. This is common again because they are the side swimmers. And they can look a little shrimpy, I suppose, as well. And they tend to be, this is another thing, they tend to be kind of rounded like a C shape. So you'll find them on their side also rounded. Now, sow bugs are also a crustacean. They also have 7 pairs of segmented legs and 2 pairs of antennae. But these are not flattened side to side, but flattened from top to bottom. So when you see them, you're not seeing them on their side, you're usually seeing them just kind of the back view. They have a deeply segmented body. So each of these segments, you can see we have a deep indentation between them. These also have an enlarged final segment of the abdomen. So in this image on the top, the head is facing towards the right, and the end of the body is facing towards the left. This is this top image. So we can see this final abdominal segment is much larger than the other segments of the body. That's another distinguishing feature of the sow bugs, and you can see that in this image on the bottom as well. Now these are also called, you may find them terrestrially and call them a roly-poly. Or, a pill bug or whatever, potato bug. There's so many names for sow bug, but this is just the aquatic version of that. So just to summarize the differences between these two, the sow bugs have that enlarged final abdominal segment, while the scuds are more rounded, and we have, it's kind of like 2 bits poking out. They're called telsons at the end of that abdomen. The sow bugs are flattened from top to bottom, and the scuds are flattened from side to side and always swimming on their side. The crayfish is another crustacean that we'll find. Generally, people are pretty familiar with the crayfish. Kind of look like a little lobster. The first pair of legs have those pincers on them, right? So this is another one. You don't want to stick your finger in the crayfish's face. It might get you, but you can pick it up from the abdomen, and that should be fine. These come in a wider variety of sizes than I think people realize. But because all phases of the crayfish are found underwater, We could find it in a first instar or very young, very small, sort of transparent, all the way up through, the fourth, fifth instar, where it's much larger, has a much more kind of bulky exoskeleton. So the segmented worms, we divide these into two different types. We have the leeches and the aquatic worms. So the leeches are flattened from top to bottom. They have these deep segments along the whole body. And of course, they have those suckers at both ends. Aquatic worms are more cylindrical or rounded. They are also segmented, but usually not as deeply segmented as the leeches are. And they can have short hairs at the bottom where they kind of nestle down into the soft sediment. So looking more closely at the leeches, we're looking at these as a class. So very high up in the taxonomic classification, lots of variety then under this category. So we could find leeches that are kind of small and plump and round and white. We could find leeches that are long and lithe and dark brown and move a lot throughout the tray. There's an image here. You can see how they move. They just attach a sucker, then they reach out and attach that sucker, and they pull this up. So this is how they kind of move around your tray. If you do find them attached to your body, don't freak out. You can just pull it off. It's just like a mosquito. They're just trying to eat. So, if we do find a lot of leeches, if we're in a system where we are finding lots of these, we will do some checks on our ankles and feet just to make sure we're not bringing any home with us. But generally, this is not a huge problem. Aquatic worms, also in this kind of class or subclass, lots of variety in colors and sizes. Some of them are very pink and plump, and they look how you might think of an earthworm. Others are very thin, like a hair, and in the net, they just kind of turn to mush when you try to pull them out of the net. And there's everything in between. So lots of different worms. But for us, pretty easy to make this identification because a worm is just a worm. We catalog them all the same. So now we are moving on to our clams, our bivalves. So the most important thing with clams and mussels is that this is a two-piece shell with a hinge. So it has to connect on one side and it has to be closed, meaning there has to be someone home in order for us to count a clam as a macroinvertebrate on our tally sheet. We will find lots of clam shells and mussel shells just around. So we are only counting ones that are still alive. Now, the reason that I emphasize the hinge part is that there's a type of snail, the limpet, that tends to be confused with the clam because it's more flattened on the top and it just kind of has the shell on the top. But it does not have the other side of the shell with the hinge connected. It has to be connected and closed to be considered a clam or mussel. Now, we're not doing any preservation of clams or mussels, but I'll just mention in case you ever do get into that in the future. Mussels lots of mussel species are pretty endangered or threatened here in New Jersey. So if you do find a freshwater mussel species, you don't want to preserve it. You'll want to take pictures of it, of the top and also of the hinge. And then we can try to do those identifications, back, just looking at your photo. But we don't want to kill them because they're threatened, obviously. So on to our snails. We divide these into two types. The first type are lunged. So they come up for air and they go underwater. They don't really rely on dissolved oxygen underwater. So you can imagine that the lunged snails have a higher tolerance to pollution than our gilled snails do. The gilled snails If you face the opening towards you, the opening's on the bottom and facing you, gilled snails will open on the right-hand side. So you can see in these images on the right, pointy bit facing up, the opening is facing us, and it is skewed towards the right side. We see also an operculum that could be covering that opening as well. On the left, our lunged snails don't open on the right-hand side, they opened on the left-hand side. So we can see again, the pointy bit is facing up, opening is facing us, and it's on the left. So right-handed snails are all gilled. Left-handed snails are all lunged. We do find other kinds of snails where you can't really use that, like the side that it opens to help with the identification. Things like the limpet that I mentioned, or the orb snails, which are just rounded. In those cases, both of those examples are also lunged. So right-handed are gilled, pretty much everything else is lunged. So a way to help us with this is left equals lunged and gilled equals good. I mean, you don't have to remember that part, but left equals lunged, right equals gilled. That's generally how it goes. So here is our sheet. I believe we went through all of these different taxa. Did we miss anything? Yes, of course we missed so much. There's so many other bugs that we could find in our streams. Here are images of just a few. Planaria are always exciting. I love to see a planaria in the fields. There's lots of other true flies. There are water boatmen. There's pupa. Tons of stuff out there. We want to make sure that when we do our identifications in the field, that we are not trying to lump every bug that we find into one of our 22 categories. So we want to make sure that we're looking for those features to make sure that a caddisfly is a caddisfly, and that we're not just trying to kind of look at this moth, for example, in the bottom left and lump him in with another species. He's his own thing. And we can jot it down on our data sheets that we've found these other taxa in the field. We just would not count that towards our minimum of 100 organisms to make our assessment and to add to the tally sheet. So now we're going to take a look at a dichotomous key. This is, there's so many different versions of dichotomous keys out there, or guides to help us walk through step by step how to make these identifications. So what we just did is we went over the key features for each of these taxa we're looking at. Now we'll look at a tool that will help us to kind of make these assessments in the field live. I will have copies of this dichotomous key for us to practice with tomorrow as well. So let's work through this together. This is the front page of this dichotomous key. This particular one came from Stroud Water Research Center. And I figure we can look at this specimen on the left and see what we come up with. So the first question on this dichotomous key is asking us if this specimen has jointed legs or no jointed legs. So you can put in the chat, if you can, if you think this has jointed legs or no jointed legs. Yes, absolutely. We do have jointed legs. We can see the little bend here. So voila, there we are. And how many legs does it have? We can either say 10 legs or more, 8 legs, or 6 jointed legs. And in this case, yes, we do have 6 jointed legs or 3 pairs. Beautiful. So we're going to flip to page 3. Here on page 3, we're starting with all the organisms that have those 6 jointed legs. First question here is, does this come in a portable case or no portable case? So it's pretty obvious, no portable case. Oh, dang, I went too far. So no portable case for sure. The question after that is, does it have wing pads or none? Those toughies, right? Does it have wing pads? I don't know. It's really hard to see. I've tried to adjust the contrast a little bit, so you might be able to see the differentiation between the thorax. So we have the head, the thorax just below this, and then the abdomen below that. So along the thorax, you may see inverted triangles coming down over the abdomen. Those are going to be our wing pads. So yes, indeed, we do have wing pads in this example. That takes us to page 4. The first question here is, do we have tail filaments or no tail filaments? And then we have to guess or go with how many tail filaments we've got. So do we have tail filaments? And if so, how many do we have? Yes, absolutely. In this case, we definitely have tail filaments, and we can see 1, 2, 3 of those. So that gets us into, well, one of these two categories here. We do have tail filaments. We're looking if it has abdominal gills or no abdominal gills. We are seeing, I see, yes, someone says we do have abdominal gills. Excellent. And that puts us in this category, which is our mayfly. All right. So this is a tool that I hope we will get used to when we practice with it tomorrow. And I think it'll be something that you'll come back to over and over. We'll also have laminated keys in the fields that are kind of wider, have all of the bugs on a single page. Like I mentioned, there's tons of different options for these keys. So I'm just presenting one of those options. Also from Stroud, I'd like to bring your attention to this website here, macroinvertebrates.org. This is just a wonderful website that they've put together where you can click through these different taxa. They have wonderful images that you can zoom in on very, very closely to look at the head, to look at the gills, to look at the tarsal claws, look at all of these distinguishing features pretty close up so that can help to kind of build your comfort level with the organisms that you'll find in the field. There's also quizzes and cool stuff like that. So I encourage you to check this out. If anyone would like to go to macroinvertebrates.org, there is a key there that you can work through for this little mini pop quiz. So I'll give you all a second to kind of settle in. What we'll do here is I'll go through some images of some bugs that we've just learned about. I encourage you to look at macroinvertebrates.org as we're going through this. I'll show you an image, give you 20 seconds to go through the key online, and then hopefully we'll find the right answer and we'll kind of look at it together. So as you come up with your answer, you can just jot that down in the chat section. I see that we have a question from Chris. Why are some of the common insects not on our tally sheet? So this system, this was calibrated by DEP, and they did choose the most common insects that are found in New Jersey. So the ones that I showed are like the mosquitoes and the planaria. They are, of course, we have mosquitoes. Of course, we have planaria. But it's likely that we're not going to find mosquitoes, say, in a flowing water system. They tend to congregate in those ponds and slow-moving ditches, where they can procreate really, really quickly. So they've tried to put the emphasis on those insects that are most common to New Jersey streams. I don't know if Debbie, you want to hop in to provide anything else from like the DEP side on the bug stuff.
Yeah, so there was a study that looked at the different macroinvertebrates that were found in different streams. and compared to the water quality measured in other ways. I don't recall exactly, but like, for example, dissolved oxygen or nutrients, and then used some statistical methods and like which organisms would be good indicators for saying something about what the water quality is. So if there was an organism that was found everywhere, then it wouldn't be a good indicator of whether the stream is clean or not, because you would find it everywhere. If there was something that was super rare, that also wouldn't be helpful for telling you, because you wouldn't be you wouldn't be finding it very often.
Yeah, definitely. Thank you, Debbie. That's a super good point. And I think maybe one of the best examples of that are the true bugs, things like back swimmers and water boatmen. They're lunged, they breathe air. They are found pretty much in every water body in one form or another, in some density or another. So that's a good example of ubiquitousness that we would not count. Yeah. Thanks for the question. That's a good one. Okay, pop quiz time. No pressure. Come on, we're just going through the key to look at these features. We will start with this young man. I'll give you just a few seconds. Take a look. And if you have a guess, you can unmute or pop that in the chat. This is a dipteran, definitely. This is a true fly. So under that category, which true fly it is, we do have it in the comments. A midge. Excellent. Yes. So we have the hardened head capsule here. We've got the pair of prolegs just below the head and at the end of the body as well. Nice. All right. Next one. Yep, we've got a few answers in already. This one is a scud or side swimmer, shrimpy, and found on the side. Whoops. I think someone has taken over. I'm going to request that back. Interesting. Gremlins. I think someone has is sharing their screen. So if you could just check and unclick the share content button, I think that would be good. And I'll try to reshare my slides. Good, we're looking at the agenda. All right, I'm going to see if I can just one moment, please. So David, I think it's your screen that we're seeing. So if you could try to click unshare, I'll reshare my screen. See if that will just override it. All right, sweet. So we'll head back. No peeking. Oh boy. All right, here we are. Turn off the presenter mode. Okay. Nice. Mark, already on it with the answer here. So we do have a mayfly. You may be thinking stonefly because the stoneflies have two tails, right? But the mayflies can have two or three tails. So the gills, yes, absolutely. So the mayflies always will have the gills along the abdomen. Here they're kind of rounded. The stoneflies will never have those gills along the abdomen. Instead, they'll be along the thorax. But really nice. You guys are quick. All right, next one. Like we have consensus. Nice. All right, we have a damselfly. Excellent. So we've got the three pairs of jointed legs, as just streamlined body all the way down with these three more paddle-like gills at the end, not the tails. And if you were to flip it over, you would see that lovely lower labium as well. Have our next example. Hmm. Interesting, interesting. Okay, so let's point out just a few features. We've got, now this is a tough one to kind of look at digitally. Perhaps in real life, this would be more apparent. But with the caddisflies, we'll have that hardened capsule at the head and either one, two, or three of those thoracic segments, and then the rest of the body would be fleshy. With the riffle beetle larva, you've got that hardened segment, brown, dark brownish to black, all the way down. So this has that coloring all the way down. And we also have possibly an operculum that's opening at the end of the body. So remember, the caddisflies will have a pair of prolegs at the end of the body. The riffle beetles will not have prolegs. They may have that operculum opening. So any questions on the riffle beetle versus caddisfly? This is one I think real life will help us make that call. Okay. So we'll move on to the next one. Now we're going to look at some side by side. So first we can start with this specimen on the left. What are we looking at here? And on the right, we have a stonefly. Yes, so on the left, we have a mayfly. Now, why is that? It's got the gills along the abdomen and two or three tails. The stonefly on the right, no gills along the abdomen, two tails. And do we see maybe some hairy armpits under there? Nice job. Okay, here's another side by side. So you can, in the comment, if you like, left X and right X. Wonderful. Yeah. So on the left, we just got a good look at one of these guys. That hardened body all the way down with that open operculum at the end. We have a riffle beetle on the left. I should move that font over to the left. On the bottom right, we have a caddisfly. So you can see that hardened bit on the head, that first thoracic segment, and then fleshy the rest of the way. The caddisfly has the pair of prolegs at the end of the body, each with a hook. And the riffle beetle has an operculum that might open to show gills. So riffle beetle on the left, caddisfly on the right. Nice. Okay, next one. Yes. So on the left, yes, indeed, we do have a sow bug, flattened from top to bottom. We do have 7 pairs of legs, this enlarged final abdominal segment, very long antenna. On the right-hand side, we do indeed have a Dobson fly larva or Hellgrammite, however you prefer to say it. So sometimes these get confused because of the number of legs that a sow bug has versus these abdominal filaments that are sticking out. So I just want to make sure that you can see the difference between these jointed legs on these first 3 segments along the thorax, jointed legs, and then beyond that on the abdomen, it's just that filament. So no joints there. It's a little bit, it can kind of move a little bit more than the jointed legs can as well. So yes, sow bug left, Hellgrammite right. The Hell's bite, they do, yes, they've got pretty big mouth parts you can see, and they kind of bring them together, tink. So if your finger's in there, it's just a little pinch, if that does happen, it does rarely happen. I don't want to scare anyone away from the Hellgrammite, even though they are named after hell. This next example, we can say, oh, the adults are so scary. I totally agree. Dobson fly adults, huge, 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 huge. Be tough. I hope that we can see all the features of that lower specimen, especially on the underside of the abdomen. Okay, so yes, we do have the caddisfly on the left. We have the head, one hardened plate, and then the rest is the green fleshiness, parapro legs at the end of the body. Now, what do we have on the bottom? Also a caddisfly, but it is a net spinning caddisfly. So we have to differentiate these from the other caddisflies. Now, why is this different? We have 3 hardened thoracic plates. So we see the kind of brown bit just below the head, and then it's fleshy on the abdomen. We do still have the pair of pro legs at the end of the body, but the net spinners may have this kind of branching gills on those pro legs. And what may be really hard to see in this image are the gills on the underside of the body. So we've got these branching white gills that should be pretty obvious when we're in real life. And I'm sure we'll get a chance to compare these tomorrow. All right, I think just one more. Yes. Do we have consensus? Beautiful. All right. Yeah. So on the left, we do indeed have a black fly larva. Kind of looks like that bowling pin, right? So the head is facing towards the right, that hardened capsule, and we have this bulbous butt. On the bottom right, we do indeed have the crane fly, a bit more of a rounded head, and no hardened capsule there. It could be retracted into the body, but we have the spiracles, this star shape at the end of the abdomen. Beautiful. All right. So that, oh, are they not the same size in real life? That's a very, very good point, and I'm so glad that you brought that up. And I should totally put a size reference with each of these images. Absolutely. I think to start, yeah, definitely not to scale. The black fly larva tends to be much, much smaller than the crane fly. Yes. So I think to start, I like to look at like the specific features of these organisms to compare. And then as we get our hands on them and look at them, we can start to get a feel of those size differences. The crane fly tends to be bigger than the black fly larva.